All right, let's look at this problem. The problem says find the last non-zero digit of the factorial of a given non-negative number n, which is pretty straightforward. So for the understanding part, it's pretty clear the input will be a non-negative number n, and you can also I can also assume that it is an integer because the factor is the factorial. So the other thing about this is the output. The output is the last non-zero digit. So let me try to understand what it means in an example. For example, I'm going to find the last digit of 4. The output would be 6, since the factorial of 4 is 4 times 3 times 2 times 1, which is 20. Is that 24? Oh, yeah. So that should be 4. And if there's another, if it becomes a larger number, if n, for example, is input is 5, my output would be what? Since 5 factorial is to the 120, so it should be 2. I think I get the point. So for the match part, this is pretty similar to the number to calculate the number of trialing 0 point is the last digit of factorial. Similar number of trialing 0 by factorial. So there's something that I have in mind is that there's always 0 trailing 0 as n is greater or equals to 5. And also the factorial will the result of factorial will grow very rapidly. So for this problem, maybe while loop or for loop, while loop to get rid of the 0. And what reminds me is that the number of challenge 0 is take advantage of the 5 times 2 is equals to 10. If you calculate the number of 5 and number of 2, when you do some calculations, and you get a challenge 0, and that's actually where the 0 come from, and that's what we want to get rid of in this problem. So let me do a plan now. So first of all, I want to get rid of the simplest method is that I calculate the result of factorial and then get rid of all the zeros. So actually the for loop to calculate the factorial of n, and then while loop to get rid of the 0, the trailing 0. but this will blow up as n becomes a little bit larger. So another method is showing up here. There's a better solution. So there's a formula to calculate it based on the number theory. I'm not going to prove it. And another thing is that there is a D1 to D9, which is the last digit of the factorial from 1 to 9 is pre-calculated, and it is used in this recursion function. So based on this, you can try to implement this. So my new plan would be rather recursive function and calculate I want to judge whether the tens digit judge if tens digit is odd, I will do something else. If tens digit is even, I will do something. And if it's less than 10, I'm going to return pre-calculated numbers. So that's my plan. I'm going to implement this. So for the recursive function, I'm going to define last non-zero digit, put in a n. If 10 is odd, so if tens digit is odd, how to get a tens digit? So the way I would do it is if so n mod 100 into division by 10, and we get the tens digit. Tens digit equals to this guy. So if 10 digits is odd, so if tens digit, if it does an AND operation with 1 is equals to 1, which is odd. So I'm going to call the same function again. So I'm going to return 4 times last nonzero digit and divided by 5 times unit of n is the last digit. So last non-zero digit, and mod 10. And it's a problem that it will we need to get the last digit, so it's better that we get the whole thing in a mod. I'm going to do this mod 10. So else, so else I'm going to return this. So what is the base situation? I'm going to return recalculate numbers. I'm going to return something. If n is less than 10, I'm going to return something. So I'm going to define a recalculate table like this. Look up the table. Which means I'm going to do something like this. I'm going to do a table equals to 1, 2, 6, 4, 2, 2, 4, 2, 8. There you go. And I'm going to return the table number of table n minus 1. So I think that's pretty much it. So after the implementation, I'm going to review. I'm going to do the review in the Python tutor. So I'm going to do this. So I'm going to last non-zero digit, for example, 5. I think you add last non-zero digit 13. Print. I'm going to visualize this. So for 5, I think it's easy because you can look up the table and it will return 2. I will print 2 here. For 13, I'm going to go through the 10th digit. 10th digit is 1, and it is an odd number. So it will go through 4 times the thing, which is 2. And then return this, 8. Okay. So another thing is to like the factorial calculator. So double check 13 is Chinese non-zero, last non-zero digit is 8. So it's 8. So I think we got it. Am I going to do the evaluation? So for this problem, actually the space complexity is all of 1. The table is pre-calculated with a constant space. And for the recursion, as you can see, there is if. It will only go through one of the if statement, and then go through the return, and then this kind of things, last non-zero digit divided by 5. If it is greater than 10, it will go through another loop. And so actually it's a log n here times a log for the non-zero digit here is it's not log n, it's all of 1. So log n 4 times, so this is log n. This is all log n, so I think the time compressor is log n. And that's it. Thank you.